An angle is a shape formed when two rays meet at a common point. We call this shared endpoint the vertex. Measuring an angle is a way of calculating the exact amount of rotation between these rays. If the two rays overlap perfectly, they form a zero angle of 0 degrees. Once the top ray begins to open, any measurement less than 90 degrees is classified as an acute angle. When that rotation hits exactly 90 degrees, it becomes a right angle, which we mark with a small square. Anything wider than 90 but less than 180 is an obtuse angle. At exactly 180 degrees, the rays form a flat, straight angle. A reflex angle continues the rotation past that flat line, and a complete angle finishes a full circle at 360 degrees. Every angle measurement in geometry represents a specific stop on this 360-degree journey. To identify specific angles in a diagram, we use a three-letter name, like angle AOB, based on the points on the rays and the vertex. The vertex must always be the middle letter in the sequence. When two angles share a vertex and a middle side, they are adjacent angles, like two rooms sharing a wall. If the outside sides form a straight line, they become a linear pair. Their sum is always exactly 180 degrees. When two lines intersect to form an X, the angles facing each other are vertically opposite. Because they mirror each other across the vertex, these angles are always equal. These physical relationships provide the logic needed to calculate missing values when lines cross or touch. Some pairs are defined entirely by their sum. If two angles add up to 90 degrees, they are complementary. Supplementary angles sum to 180 degrees, and explementary angles sum to a full 360 degrees. Let's try it. If an angle is 40 degrees, what is its complement and supplement? Subtracting 40 from 90 gives a 50-degree complement. Subtracting 40 from 180 gives a 140-degree supplement. Unlike structural pairs, mathematical pairs don't have to touch. Their relationship is based purely on numbers. Apply these definitions to this detailed diagram. The baseline shows a linear pair. The intersection creates vertically opposite angles, and this 90-degree corner indicates these two adjacent angles are complementary. Complex geometric figures are constructed from these basic building blocks. This chart summarizes the measurement ranges we've discussed. For pairs, focus on the required totals: 90 for complementary, 180 for supplementary, and 360 for explementary. Committing these specific numerical sums to memory makes it easier to identify geometric relationships.